Okay, folks, I gave this talk at a conference a while ago, and it was a really interesting one, and I wanted to share it with all of you here today as well on PHP Annotated. So let me tell you two stories. The first one is about this. That's my name, but actually you write it like this. But for some reason, I decided to write it like this. Now, I'm from Belgium, which means that my native language is Dutch, where we have a very weird grammar rule. When you have a verb that ends on a D, you sometimes add a T, but sometimes you don't. And this is called the DT rule. Now I'm super bad at it. I don't know why, but it's super confusing to me. So when I had a teacher in high school who was part of a Facebook group called "The DT Rule Isn't Difficult, You're Stupid," well, I deliberately started writing my name with DT on all of her tests because, that's the kind of rebel I am. Now, it stuck though, and I started using the DT version online because it's less common. But actually, I usually write it like this because of reasons, but that's another story. Now, why am I telling you all of this? It's a very elaborate way of sharing my social credentials with you at the start, but it's also a segue to the rest of this talk, which is about language as well. I want to tell you a second story about languages, and especially about the weird edge cases you encounter when dealing with languages. Now, real quick though, because I already plugged my socials, I'm Brent. Write it however you like, it's fine. I'm a developer advocate for PHP at JetBrains, and I have this blog, some people might have heard of it. It's called Stitcher.io. Now, on this blog, I write about PHP and programming in general. So you can imagine how it contains a lot of code blocks. Now, this is where my problem started many years ago. I wanted these code blocks to look exactly like how they would look in PHP Storm. They had to be styled properly. And I don't know if it's just me, but I get really annoyed by code blocks that aren't styled the way they should be styled. And so back in the day, there was a library called Highlight.js. And it worked pretty well, even for PHP code. But of course, PHP evolved, and it turned out that Highlight.js was a bit slow in getting support for the latest and greatest PHP syntax. On top of that, Highlight.js was running on the client side, often leading to these flashes of unstyled content when you loaded the page. So at some point, someone made a PHP implementation of Highlight.js, which you could run on the server. And someone else made a common mark plugin using this package so that markdown code blocks were rendered with highlighting included. And that solved one of my issues. No more client-side rendering. I could render and cache everything server-side, and that was pretty good. And unintentionally, it also solved the other issue I had with unsupported PHP syntax, because this renderer was running server-side. So I figured, why not do some manual processing on my code blocks as well? So I introduced a special tag that I could use to manually style parts of my code that weren't properly handled by the package. Now, in hindsight, I don't know, but this was such a crazy thing to do, but I got used to it and it worked. And I didn't really mind that I had to micromanage every code block because, I get really annoyed with code that isn't styled properly. And so for me, this was worth the effort. I had these live templates set up in PHP Storm so that I could easily wrap parts of my code within these tags. And it worked. I used this hacky solution for many years. You can still find some of these Highlight.js tags in the source code of my blog. But at one point, and totally unrelated to code highlighting, I decided to build a framework, as most PHP developers do at some point in their life. So for this framework, I was also building a documentation website. And I just copied over the code rendering engine from Stitcher and I called it a day, But soon thereafter, I got a message from a good friend of mine, Aiden. And he told me that these code blocks suck and that there's no way anyone will want to contribute to such a weird system. Now, I knew that Aiden was right, but it didn't really feel like worth the effort to spend more time on finding a new solution. I wanted to write my frameworks and not the docs. But truth be told, I would say that the docs are probably the most important part of any framework or open source package's success. But yeah, that's a story for another day. I told Aiden I will spend an hour, maybe two, looking for alternatives. There probably are better solutions now that we're a couple of years later, I figured. So I did some research. Highlight.js, it still had some problems with modern PHP syntax, so that was no option. But there now also was Shiki, which from what I understand is a wrapper around VS Code's highlighter engine. And that in turn is wrapped by a PHP package that makes it available in PHP. So it actually highlights code very accurately, with the downside that it is really slow, like really slow, as in 7 seconds to render a simple blog post slow. Now, the way that I'm writing technical content is by editing a markdown file and very often refreshing its rendered contents in the browser. So having to wait 7 seconds for Shiki to re-render code blocks, that's just totally undoable for me. I don't know if that's just a me thing. Let me know if you know, like, do this as well, but I really need it. I need to see that code, that markdown being rendered. Now, there is caching that could help me out here, but I make changes to my code blocks very often while writing. So really, caching would solve any production performance problems, but it would lead to a very annoying developer experience either way. So Shiki is out of the question as well. There's another tool that wraps PHP Shiki, so a wrapper for a wrapper of a wrapper. And this one actually exposes Shiki over the wire as a service so that you can asynchronously highlight your code blocks with an external API. I'm gonna have to repeat that. This one exposes Shiki over the wire as a service that you can use to asynchronously highlight code blocks with an external API. It also costs money, but in all honesty, it's a great tool. It's called Torchlight, and I believe that quite a lot of projects use it these days. It gets rid of all the hassle, and people are willing to pay for it. However, at this point in my research, I'm like, hang on. I cannot believe that there aren't any better solutions out there. We have layers upon layers upon layers to solve an issue that at its core isn't more than simple text processing. So I messaged Aiden and told him I'm gonna spend a day or so figuring out if it's really that hard to write a syntax highlighter. I mean, it's just text processing with some regex. How difficult could it be? Now, spoiler, it actually works. I wrote that highlighter package. It does syntax highlighting in PHP server side. It's super extensible, works for the web and terminal. It's super fast as well. It's already used by many blogs and documentation websites. And, well, it took a little more than a day. But today I want to do two things. First, I want to show you how I built this package because it was a super interesting problem to solve and I think everyone can learn from it. But I also want to think about how sometimes it's worth to start from scratch and how it's good to challenge the things we've gotten used to. So first, the technical side. There are two approaches to highlighting code. You can use regex to match patterns within a string, or you could build an AST, an abstract syntax tree. Now, this solution, the AST, is by far the most flexible one. An AST is a data structure used in computer science to represent the structure of a program or code snippet. It's a structured representation of your code. Now, your code, in essence, it's just text, right? An AST is a parsed, structured representation of that text. An AST is used by compilers and static analyzers to better understand what that blob of text actually means within the context of a programming language. An AST is a tree combined of many nodes, and each node represents a small part of your code. And so when it comes to syntax highlighting, if you have an AST, you know exactly which word is what, and you know exactly how to color each word. Now, the problem with an AST is that you need an AST for every language you want to support. Now, I mainly write about PHP on my blog, but that means I need highlighting for SQL, HTML, CSS, JavaScript, JSON, YAML, probably a handful of other languages at the minimum. So if I choose the AST route, I would need a so-called parser for every language I would want to support. And a parser, that's the thing that builds the AST. PHP has a parser written in PHP. It's called, believe it or not, PHP parser. And it's, for example, used by static analyzers like PHP Stand to properly understand PHP code. But that's just one parser. And I need 10 at least. And that's just for my case. Now, on top of that, if I really want this package to be useful, it might be smart to open source it and allow others to contribute. There's only so much time I have within a day, so if other people can easily add languages as well, then the package wouldn't be so dependent on me. So that was like a key requirement. I want this package to be as easy as possible, not just to use, but also to extend. Now, with extend, I mean allowing people to contribute to it with as little friction as possible, not necessarily using inheritance, but that's also a story for another day. So regex, it turns out, is the easier solution. However, regex has its limitations, especially compared to ASTs. Regex is just simple pattern matching on strings. It doesn't know anything about scope, for example. It doesn't know whether a specific word or phrase is commented or not, unless you write very specific rules for very specific edge cases. And there are some edge cases. Regex isn't the perfect solution. But here's what I like to do in all of my programming projects. I like to optimize for the 95% common use case. And I make sure that that other 5% is covered with slightly less convenient solutions. And I figure it's better to have the 95% use case be very easy and the 5% be difficult instead of everything being difficult. Now, that might sound a bit abstract, so let me explain how this highlighter works. You start with a language. A language is represented by a class. It has a name and patterns. Now, each pattern matches a very specific regex rule. It tells the highlighter how to color the matched string. So, for example, the keyword pattern class. PHP has a bunch of keywords: return, match, new, and so on, reserved words. And so matching keywords is pretty straightforward. It's a hard-coded regex match on a specific word. And then you add as many keywords as you would like. Now, there is a problem, because what happens when a keyword occurs in a string? Then it's not a keyword anymore. If you would have an AST, you would already have known that this is a string and that the words within that string aren't keywords. But with regex, you don't really know. And you can imagine how a relatively simple regex pattern would explode into an unmaintainable mess if we would have to account for all the edge cases. However, there is a good solution, one that works in the 95% of cases. We can split our code into tokens based on the patterns we've provided. And whenever a token is detected within another token, like for example a keyword within a string, we can determine whether that child token is allowed to exist within the context of its parent. In this case, any token that lives within a string is simply discarded, because a string is a string and we shouldn't highlight anything with it. And this is basically like a very simple AST in disguise. Okay, but that's one example. Now imagine doing this for the whole language, basically. And now for PHP in the current implementation, there are around 50 pattern classes, 50 regex rules that match as small as possible a part of PHP code. And all of these patterns, they are applied, keeping into account that one rule, which determines whether a token can live within another token. And then you get pretty far, actually. So those are patterns, matching a very specific case with regex. But patterns on their own don't suffice. There are cases that need something else than just patterns. And this is where injections come in, where a pattern targets a very specific part of our code. An injection is meant to target large blobs of code. Think of an injection as injecting another language into an existing one. A good example is SQL, right? Because SQL injection. Now, you want to highlight SQL code within PHP code, right? So injections, they target larger parts of our code, also by using regex matching, but they don't return one specific token type that's used to color one word. Instead, they re-render parts of our code as something else. Like, for example, everything within SQL here docs should be highlighted as SQL. Now, injections are useful for other things as well. For example, doc blocks in PHP. Doc blocks, they need some styling for type definitions and stuff like that, but they should also be styled as comments as a whole. And those types of highlights are possible thanks to injections. And so basically, that's all you need. Patterns and injections. Patterns match very specific words, and injections match blobs of code that can and render them as different languages. Now, the difficult part is making all of these things work together, and that took me several days, early mornings, late evenings, to get it right. In essence, it's nothing more than string manipulation based on offsets, but it takes a while to get it right. But eventually, I was able to build something that works pretty well. And just to show you how easy it is, I want to implement a language for this highlighter package right here and now. PHP is a big one, but Blade, for example, Laravel's templating engine, can be written with just a handful of patterns and injections. So let's take a look here. I have an example, a test file here with some Blade code. And as you can see, there's no highlighting here except for the HTML tags. And that's because if we go to our Blade language here, I have some prepared. It extends from HTML language. So basically we say that everything that is Blade is also HTML. Blade is a subset of HTML. Now, let's start with highlighting keywords here. Everything within a Blade file that starts with an @ is considered a keyword, right? And let's create such a keyword class. Let's go over here, create, what did we call it? Blade keyword pattern. Like so. We implement a pattern, because this is a pattern. And then we use a trait, is pattern. It provides like some part of the default implementation here. And then we have to do two things. We need to provide a token type, and this is the thing that determines the coloring. And we have an enum for that, token type enum keyword, because we are working on our keyword pattern here. And then we need to write a pattern. Let's see, it shouldn't be all that difficult. Let's actually use this one here. Everything, I think this should suffice already. So everything that's suffixed with an @, actually let's move the @ over here. I'll explain this match over here in a second. Everything like single words, all alpha characters that are superseded by an @ should be treated as keyword patterns. That's what this regex is saying. Let's take a look whether this actually works. And it does. Now, circling back to that @ here that I moved outside the match, this is like something you need to know. Depending on like the kind of pattern you're working on, you might not always want to color the whole word, right? So that's why there's a match here, a named capture group, basically. If you would move the @ over here, the highlighter package would also color that @. And that's useful in many cases, like for example, coloring HTML tags as well. Now, the second thing we can do is anything that starts with a keyword and then brackets, and then basically the body over here, that's interpreted as PHP code, right? So I already have this one in place, where we have kind of similar pattern. We have an @ with some like alpha characters, and then our pattern says that we need a bracket. Then we open our named capture group, and then basically everything within that those brackets, because here's the closing bracket, that's being treated as, well, this is an injection, so not just as a single keyword, but it's parsed as PHP, right? So let's add this keyword PHP injection as well, and then we should see this, being colored over here. Same for, let's see the comment pattern. This is pretty straightforward. Anything between these tokens here is considered to be a comment. Let's add that as well. That's our comment. And then finally, we have our echo injection. Basically, anything within echo tags in Blade is also considered to be valid PHP code. So we add this as well, and then these parts are colored as well. And that's already like the majority of Blade done. Basically, Blade is a very simple language to make a highlighter for. 4 patterns, that's all you need. Well, 2 patterns and 2 injections. Now, you get an impression of how easy it is to actually add support for new languages. And yes, things get a little more complex for languages that are larger than Blade, but it's pretty easy and straightforward. So if you would like to learn a bit more about how that rendering process works under the hood, I made a video about this highlighter package where I explained a bit in depth what's going on behind the scenes. I also wrote a blog post about it as well. You'll find the link in the description, I reckon. But we're not done, because remember how I mentioned that a handful of very specific code blocks might be too difficult to accurately parse just with regex. Now, I told you I have a blog where I write about PHP, and I have a lot of code blocks. Personally, I haven't run into too many problems, and if I run into problems, they are bugs that I fix. But just in case, I also made sure that code blocks can be rendered correctly for those 5% of cases. So I added some special tags, just like I did with Highlight.js solution, which allows people to micromanage how their code is rendered, just in case. And I think it's important to have a solution in place for those edge cases, but I don't think it's important enough to warrant a whole different approach that would affect the 95% case as well. Now, for me, this is something I really believe in when it comes to software development, and I would like to invite you to think about it as well. If there's one thing I hope you take away from this talk, it's to focus on the 95% of use cases and not get stuck on the 5% of outliers. And the second thing, if there are 2 things you take away, is that you dare to rethink your current solutions. Remember, we started with a wrapper for a wrapper of a wrapper to essentially highlight text. And we as developers, we have the unique ability to write code to solve problems. And sure, it's probably more difficult than what you first thought it would be. But the result might very well be better. The result in my case, it's a highlighter that's more performant, it's more accurate, it's super easy to extend, it doesn't involve multiple layers of applications and APIs to go through. And I want to challenge you, the next time you encounter a problem, dare to question the current solutions. Oftentimes, the current solutions are great, but sometimes, just sometimes, there actually is room for improvement. Thanks.